Hello, everyone, and welcome to Kutsuo Academia. We've all had the flu at some point, or at least we think we have. But this super common illness is actually one of the most misunderstood. It is so much more than just a really bad cold. And today, we're going to deconstruct what makes influenza such a powerful and, honestly, a fascinating virus. To kick things off, let's just put its impact into perspective.
Take a look at this number, 500,000. Now, that's not the number of flu cases in a year. That's the estimated number of people who actually die from influenza-related complications every single year, all across the globe. It's a pretty sobering number, and it's a huge reminder that what we often just brush off as the flu is a really serious global health threat.
And it's not just me saying it. The research puts it really bluntly. Influenza is a highly contagious, deadly virus. So this isn't just about feeling crummy for a week. It's a virus that really demands our attention. So let's dive in and see if we can understand it a little better. To really get a handle on this, we're going to break it down into 4 key areas. First, what makes this virus such a tough opponent? Second, we'll look at the virus's secret weapon, its shape-shifting trick that lets it come back year after year. Then we'll get into the incredible global race to create a vaccine. And finally, we'll talk about what might be the biggest hurdle in all of this, which is us. Okay, first up, a formidable viral foe. So what is it really that separates influenza from all the other bugs out there that just make us feel under the weather? Well, it all starts with the virus family itself. There are 3 main types that infect us humans: A, B, and C. Now, type C is super mild. You might not even notice it. Type B, it can get you sick, but it usually causes less severe, more localized outbreaks. But the one we really have to watch out for is type A. That's the big one. It's the one responsible for our seasonal epidemics and, even scarier, global pandemics. And a huge reason it's so dangerous? It can jump between animals and humans. And of course, the second you start to feel that tickle in your throat or a bit of a fever, this is the question we all ask, right? Is it the flu? Is it COVID? Is it just a cold? Or maybe my allergies are acting up? The symptoms can feel so similar, it's just really hard to know what you're dealing with. So even though there's a lot of overlap, there are some clues you can look for. For example, those really deep, all-over body aches, that's a classic sign of the flu or COVID-19, but you don't usually get that with a common cold. On the other hand, a lot of sneezing, that points more towards a cold or allergies. And of course, the really big giveaway for early COVID was that strange loss of taste or smell. So it's not just one symptom, it's the combination of symptoms that helps you figure out what your body is actually fighting off. But what makes the flu so persistent? I mean, why does it keep coming back? That brings us to its incredible shape-shifting trick. This is the absolute core reason it's such a relentless enemy and why we need a new vaccine every single year. So the first part of the trick is something called antigenic drift. The best way to think about this is like a spy who keeps slowly changing their disguise. The virus makes these tiny gradual changes to its genes over time. It's not a complete makeover, but it's just enough that the defenses your immune system built last year might not recognize it perfectly this year. This is what drives the seasonal flu we see every winter. The second trick, though, this one is much more dramatic. It's called antigenic shift. Now, this isn't a new disguise. This is like a completely new spy showing up on the scene that no one has ever seen before. It's a sudden major change that can happen when different virus strains, say one from a bird and one from a human, mix their genetic material together. The result is a totally novel virus that our immune systems have zero experience with. So let's just break that down one more time. You've got the slow, gradual drift, which causes our predictable seasonal flu, and where your immunity from last year might still give you a little bit of protection. But then you have the sudden, dramatic shift. That's what can create a brand new virus that nobody has protection against, and that is what has the potential to cause a global pandemic. Understanding how the virus mutates leads us right into our next section, the race for a vaccine. This is the really incredible story of this massive, global scientific effort to protect us from a target that is, constantly on the move. And this is a huge undertaking that basically never stops. For about 6 to 8 months every year, this global network of labs acts like detectives, tracking which flu strains are making their way around the world. Based on all that data, the World Health Organization makes its best guess for what's coming next. Then, here in the US, the FDA makes the final call, and only then can this enormous job of producing and distributing millions of vaccine doses even begin. But remember antigenic drift? Because of that, making the vaccine is always an educated guess. Scientists have to predict, months in advance, which strains are going to be the most common. When they get it right and it's a good match, the vaccine can be around 60% effective at preventing illness. But if the virus zigs when they expected it to zag, that effectiveness can plummet, sometimes to as low as 10%.
And here's a really crucial piece of information to remember. The vaccine is not an instant shield. After you get the shot, your body needs about 2 weeks or 14 days to build up its full antibody protection. That's why you always hear the advice to get vaccinated early in the season, before the flu really starts to spread. And all of this brings us to our final and maybe most important section, the human hurdle. Because look, developing a vaccine is an incredible scientific achievement, but a vaccine that just sits on a shelf doesn't protect anybody. And this is where we see this huge disconnect. In the US, for instance, the public health goal is to get about 80% of the population vaccinated each year. But what's the reality? Well, only about 45% of people actually get their annual flu shot. That is a massive gap between where we need to be and where we actually are. So why? Why is there such a big gap? Well, research points to a few key reasons. There are these persistent myths, like the idea that the vaccine itself can give you the flu. There's also a general lack of awareness about just how severe the flu can be. And then you have other concerns, everything from worries about side effects and a fear of needles to just not having easy access to healthcare. And this is maybe the most important takeaway from this whole discussion. Getting vaccinated, it isn't just about protecting yourself. It's about protecting your entire community. When more people are vaccinated, it builds this sort of wall of immunity that shields the most vulnerable people among us, like little babies, the elderly, and anyone with a compromised immune system. And that leaves us with a final, really important question to think about. Science gives us the tool to fight this virus, but what does it take for us as a society to actually use that tool effectively and protect everyone? This has been Kutso Academia. Please be sure to like and subscribe.